maybe regarding the course. It's not the course regarding the topics we were concerned on the free undamped vibration. We are talking only for one single degree of freedom. So let me share with these. Let me share with this another slide here. This one. So you can turn to page 253 on this particular uh, example. And before we do anything, we'd like to make a small correction here. The correction will be, okay, yeah, the correction. This one is not in your notes or it's not in your book. Yeah, please put it this sentence. Otherwise, the solution will not be comply with the theory that we learn in class. Yeah, so this is correct. Determine the frequency of system for a small oscillation, correct? And perhaps we have to put another consideration. This one, this is a new one. If consider the effect of gravity, is typically considering the effect of pendulum. Even though we already defined pendulum, this one is not been considered as pendulum because it be constricted by K, isn't it? Or be controlled by K. The motion is not a free motion, or it's not a free oscillation. So, but the equation asks us to consider the effect. So you need to put on, or you need to counter, or you need to consider the effect of gravity. Huh? So you have to read the equation very, very careful. Sometimes we did not mention about considering anything about it, so you have to ignore because this K will be controlling the mg and there's no mg sine theta here. So in the solution, you found that the solution. So if I can go back to the solution, if I have a solution with me here, in the solution, yeah, if I can check on the solution, you have the solution with you. It's not very difficult. We can do the solution here. Typically on on the three different methods. So I'm going to solve here with three different methods. One will be considering the Newton's law, the Newton's law here. So remember, when you're considering the Newton's law, you need to construct free body diagram. And it is compulsory to construct the free body diagram. So start with construct a free body diagram. So the free body diagram you constructed must be, you can put it here or you can put another diagram. It's up to you, yeah. So allow me, to displace this one and you release it. Displace with theta dot and theta double dot. Then the system will become here. Here is the initial line. This one it will displace a bit with theta, and this is the fixed point. Let's say it's about O. Let's say it's not about O. You will have theta dot, theta double dot. Then as you displace, then these two K here will not allow the system to move, isn't it? So it will what? It will say that don't go. Or perhaps it will bring back the displaced position to the original position, correct? So what you have here, you can put it here, you can put it here as this one. This one will be Kx. And you have another one here. This one is put it here. This one is you display this. Remember, this one is always opposed. So this is not correct. It's always opposed the direction of motion. So it basically, it's basically opposed the direction. So it will give you that way. Correct. This one also same thing. It will also give you that way. This one put it Kx. Then together with you have this one mg, and we have this one mg sine theta. And of course, it is not complete if you don't put this one mg cos. Otherwise, it's not correct, yeah? So then you found that everything is correct. So by applying equation, summation of moment about O here is equal to I O theta double dot. And saying that, rotating that one positive has been given here, isn't it? So you are saying that, okay, negative Kx multiplied by the distance here, this one is y, correct? You have another one, same thing, you have here is also Kx, also y. Then you have minus by the mg sine theta. Of course, this one, yeah, the mg sine theta, this one is not, what do you call it? It's not true, it's correct, but not by using scale. So you found that the line is basically not consistent. So this one you will have mg, of course mg, you multiply by L because the length here, this one is L sine theta. Correct? This one is equal to I theta dot, I naught theta double dot. Okay? Then because you know that this theta is this one, yeah, this x, but put it here. X is equal to y theta. Remember the segment equation? Then you put it in the equation. So you found that okay, negative k, you have y theta minus by, if I can simplify both, yeah, because you know that both have the same parameter. So you have this one y square by another y square. Just put it here, y square here. This one, yeah, y square, because y and y become y square. Then you minus by another one. This one is y square theta, isn't it? Then you have minus by mg sine theta, then equal to, and we simplify this one, I O is equal to ml square, coming from the equation that you learned in moment of inertia. You have I O equal to I naught equal to m k square, where you found that k now is equal to L. So you put it here, you have the m L square theta double dot. Okay, then you simplify the whole thing here. You have the ml square theta double dot. It's not theta square, yeah, it's theta double dot. It's theta double dot. You put it in theta double dot. This one, of course, you have plus by 2ky square theta, isn't it? Simple mathematics there. Plus by mg sine theta equal to 0. And this one you have to get rid. Try to get rid the sine theta. In mathematics, of course, you cannot just cancel off it, isn't it? So due to small oscillation, this theta, yeah. So theta has a tendency to becoming 0. So in mathematics, as theta becoming or a tendency to become to 0, you found that the sine theta, sine 0 equal to 0. So sine theta equal to theta. So you put it here. So your equation now becoming ml square theta double dot plus, this one is 2ky theta square plus mg. This one also, I miss one. I miss one. I miss one parameter. This one should be, because from the very beginning we have L here, because we are talking about moment, isn't it? So you should have L here. Put in L here. We have put in L here. Then you have L here. Theta. Then it's a square. Then you can simplify the equation. Theta double dot. Remember, plus we have two. This one theta and theta. You can bring it to the one. What do you call it? The is common parameter. It's a common parameter. So you have here is you have 2ky square plus mgl theta divide this one is divided by ml square is equal to 0. It's not very difficult, isn't it? Then you can simplify this one, because okay, so therefore equate, remember, equate with what you have equate what? Differential equation of motion of simple harmonic motion, which in term of theta double dot plus omega square theta equal to 0. So start selecting perhaps the second part or second term of the equation. This one is basically equal to that one in a good in the same manner, yeah. Of course, you found that your omega n square is equal to this one becoming 2ky square. Then this one be ml square, right? Plus m and m, l and l cancel. You have g by n. Then you give away the one, become the n. This one radian per second. Is that clear? It's not very difficult actually, yeah. So if you want to do this, for example, you can also apply another method. Remember, let solve by harmonics equation, saying that okay, let theta equal to, you can put theta dot sine omega t, and you have this one, theta dot is equal to omega theta naught cos omega t, and we have another one, theta double dot here, negative omega square theta naught sine omega t. And you take this one and you put it in the equation. Put it here. Same thing will happen. Same thing will give you the same result anyway. Okay, I'm not going to do that one. Yeah, you can do on your own. You can compare and you can practice. But I would like to suggest to you that do this one because we are not mathematician, guys. We are basically an engineer. So you use equation to solve problem. We are not creating another equation and proving the equation is correct or not. You use equation as you agree that this is coming from differential equation of motion of the simple motion. So you use this one and equate the equation, and these two equations must be in the same form. Okay, that is my suggestion. But if you want to try to this one, no, you are welcome. Okay, any question? Any question? Hello? No. Okay, now let us now try to use before that. But if the question doesn't ask you any, sorry, the question doesn't tell you about considering the gravitational effects, yeah, you found that your equation now become a bit shorter, isn't it? Your equation now become, if I can put it here, so you can ignore this one. This one not part of your solution. This one equal to 0 when G is not counted, considered lah. Consider, because this one is due to pendulum. Okay, so you have to read the equation very, very careful. So your equation becomes shorter anyway. So the next part is, we are still talking about the effect of pendulum at the moment. Yeah. So this next is by using what they call it, by using the energy methods. The equation that we use is the differentiating of Ke plus Pe equal to 0. And we are talking about equilibrium energy or conservation of energy. Yeah. So how we are going to go about it? It's not very difficult again, but of course you need to know what is the energy that you have to consider. And when you're talking about energy method, you don't have to construct free body diagram. You have to understand that when this spring will be contribute potential energy, potential elastic energy, and when you have mass here, it will give you kinetic energy. Correct. So these are the things that you should understand. So let's try to use kinetic energy. This one, yeah, due to mass, due to m. So you have it's basically not due to m. Yeah, if you read more and more books, it is not due to m. It's basically due to the weight is mg, because m itself will not give you gravitational forces. It must be due to mg. Now, if I put it due, I think if I put it due to m every, yeah, so half equal to half I theta dot square, isn't it? And this is I is about O, is about O, and you know well that as I put it the I here just now, I not become m n square, and again, you cannot run away this one from the equation I naught is equal to mk square, where your k equal to n. Okay, so that is one. The other one is due to spring, or we call it due to what? Due to elastics, due to elastic. So you have PE equal to this one, yeah. You have two, because you have two spring, isn't it? You have two springs, so you will have half K, correct? And this K will be, you know that PE is basically half KX squared, correct? This is the extension. But now, just put it here, this one, yeah, your X is not X, but put it as, what they call it, yeah? Um, displacement, displacement. It's not displacement, it's the extension, isn't it? It's the extension. So put it the X dot, X dot. Correct, isn't it? Correct, not? And what else? But you have a mass here. One mass will tell you, but now due to gravitational. This one is due to mgs now. This one, the other one is due to gravitational. So you have another one. You will have another one. So what do you have here? So remember when you study equivalent, EQUR equivalent method, you don't want the pendulum, isn't it? But you want spring. You want to put spring instead of pendulum. That is why, if you look at wash, wash, you have a wash, then you look at the kinetics. The kinetic the kinetic typically psycho wash use the kinetic. So the kinetic will basically the pendulum, but you have a capacitor there. The capacitor will basically absorb all the energy. The capacitor, it look like the flywheel, will absorb energy, when excess, and then will deliver. That is why it don't need battery, you need capacitor. That capacitor will make the system, but you need to move, you need to wear all the time the cyclokinematic system. Otherwise, the watch will stop, or the needle will not move. Okay. Now equivalent method, equivalent method, So you have to, you have to put something here. So it simply means that this one, and we don't want to put mass here. We want to put spring. Isn't it? Want to put spring. So this spring representing what? This spring representing what? Representing Kp. Remember the Kp? Kp is equal to the mg by L. Remember not this one? So you have this one. Okay. Even though you know that this one you have 2k, then you simplify this one. You have another one. Instead, you have another one spring, Okay, this one is due to pendulum. Due to pendulum, okay, due to gravitational. So your equation now, you have another one plus, this one is PE, you have another one, this one. You can put this one half, but KP lies at the end, at the, what do you call it, at the tips of the of this rod. You have L, you have the put it the KP, and put it the this distance is x square. Put it the x, but this one x and L. Put this one x and y. Okay, this one is n, also x here, but and L, because as you displace this one, let me another color, If you displace this one, for example, this one be x for L, this one be x and y, because the length of y and the length of L is representing respectively, respectively. Okay, then you start simplify this equation now. You simplify the equation, is not very difficult. You have half, k will remain as k. The xy is here. Remember the xy is equal to y theta, isn't it? And you have the xl, remember, is equal to L theta. This one is due to what? Segment equation. Segment equation. Then you put it here. You put it here, k, and we have square here, so we have k, y will be y square theta square, isn't it? But you have two spring, isn't it? You have two springs, so you multiply by 2 plus, you have another one, another spring, this one, which is basically not here, but this is due to energy, Kp. And this Kp is basically, you have the Kp is xn will be, you have L power of 2, theta power of 2. So this is the energy now. The energy is coming from the PE. The other energy is coming from the PE. As you can, do this one, then you start putting in the equation. So you have d by dt PE plus KE equal to 0. So I'm putting everything here. So you have half. This one is my K, Y2 theta power of 2 multiplied by 2 here. This one is plus. This one is half my KP. This one is L squared theta square plus. You bring up this one. You bring this one half. This one is I. And let's say that you already simplify this one. Yeah, simplify this one becoming half. This I will be ML square theta dot square. Easy, right? So when I put it here, half, and I'm going to get with this I now. So I'm going to put this M L square theta dot square. Correct now? It's the same, isn't it? So equal to 0. Then you start differentiating this one. Differentiate this one d by d. Okay, this one of course you have 2 multiplied by 2. This one is half, right? Then you have y power of 2. Theta become theta dot plus. This one you have half. So you have 2 power of 2 theta here. This one you have half. You have kp. This one is L2 theta dot plus. We have half m L2 theta double dot equal to 0. Okay, then we cancel this one, we cancel this one, you cancel this one. What else? Okay, you can't cancel any anymore. Yeah. So what you have here is I miss one. This is very typical. Sometimes I miss one term. What does I miss here? Could anyone tell me? I miss one term, one parameter. What does the parameter I miss here? Could anyone tell me?
K.
Sorry? K. Where is the K now? K is here. Supposed to be here. I left K here, isn't it? So then it's not correct. Then it is correct. K y square. You put theta plus you have this one kp L square, another theta. Put it in bracket theta dot plus this one is astaghfirullahalazim. It's not correct. Sorry. It's correct. I'm going to simplify the whole thing. It's much easier rather than put it every time. This one keep writing the same equation. So I'm going to simplify. This one is okay. This one is k just now. Y square. Put it here. Theta. Then it's correct. Yeah. Plus this one is half ml square. You have theta double dot. Then you put a big bracket here. Theta not equal to 0. Then your solution will be coming theta dot will not equal to 0. And the other one will be, this is one solution. The other solution is, second solution will be, you have half ml square theta double dot, right? Then you plus it there, ky square plus kpl square, this one is theta equal to 0, right? And then you simplify, okay, theta double dot plus this one, where do I go wrong here? I think I may do otherwise. Oh yeah, this one, where do I go wrong? Can you tell me? Anyone?
So can we replace K with the mg over L?
K, yes, correct. The other one is this one, yeah. Isn't this one? Do you have theta dot square? This one, look at it, theta dot square. When you differentiate this one, you have 2 here, correct? Then you will cancel here, correct? Yes or no? Then this one will not in your equation anymore. This one will not in your equation anymore. Yes or no? isn't it? I missed that power of 2, this one. This one, remember, this one is power of 2. Then when you differentiate this one, it becoming 2 half. This one be ml square theta dot theta double dot. Then I missed 2 here. So then you cancel that one. Okay. Sometimes you have to be very careful, yeah. I myself sometimes make mistakes. Okay, anyway, come back to here. You have ky. This one will be kp l square divided by, you put everything, this one ml square. But you also know that you can simplify this one, yeah, because you know that kp just now we have mg by l, isn't it? This is kp. Remember this kp? Do you know how this kp, the equation kp is the equivalent stiffness for pendulum representing by springs, yeah. So this one is basically, if you remember, by this one, yeah, if you remember the thing that we learned earlier, for spring mass you have equation omega n square equal to k by m, isn't it? And you have pendulum, you have what? Omega n square equal to g by n. So you equate this equation, then we'll give you one. They will provide you, and this one is basically k, but now you have k by m equal to g by n. So if you want to design this one, put it kp. So you have this equation. Okay, then we go back here. Then you found that your theta double dot plus this one be your ky square plus kp will be your mg divided by l. This one l square. This one is the divide the whole thing by ml square. Yep. Yes. Then you have theta dot equal to 0. So you can simplify this one, cancel here. Am I correct or not?
Doctor,
Yes.
wasn't the ky square supposed to have a 2ky square?
Yes, but we already canceled this one.
But there are two. But there are two, right?
This one, there are 2 here. We have, okay, this 2, this one is basically coming from the here. This 2 is coming from the power. Right? Isn't it?
Yeah.
Okay.
Yeah.
You have the 2 half. This is ky just now, isn't it? Correct? Then multiply when you differentiate, because when you differentiate, we have this one. You hold on, yeah. Where I go wrong, sir. You have theta square here. This one, you have theta square here. This one, I missed one theta square here. This one, because I do write by my writing pad is sometimes it's not it's not active. So put it here, so it becoming zap. Here, this one becoming here. Okay, or you can basically from the very beginning you can cancel this one, because you have half but you have 2, both will give you 1. Am I correct or not?
I got if the half and the 2 is already cancelled, the differentiate should have a 2 coming out, right?
Correct.
Yeah, but doctor didn't write the 2ky square.
Oh, okay. I missed this one, right? 2k.
Yeah.
Sorry for that, yeah. Because half and 2, this one cancel. I still have 2 here. Am I correct? Okay. Thank you. Thank you. Yeah. So we have 2 there. You also have this one 2 here. Quite messy now, yeah. So how am I going to solve this one? Theta double dot plus this one, you have 2ky squared just now. You have divided by, you can put this one in ml square plus ml square, and this one will be on theta becoming 0. And again, when you equate with the equation theta double dot plus omega n square theta equal to 0. So finally, you'll be getting omega n is equal to this guy, and this one can be 2ky square by ml square minus by this one cancel and cancel is g by this one plus, yeah, and this one give you inshallah the same result as previous. Does it give the same results? It's correct, yeah. This one same result as previous. Okay, sometime I do left one parameter. You check, yeah, please, yeah. Thank you for those who are correct me just now. Okay, the other part is solve by EQUR equivalent methods. So for the equivalent method, I'm not going to do this one because this one is not very difficult. Yeah. So I would like just to give you idea how you do the transfer. Okay, now I'm going to change color here, another color. So I also want to have another what do you call it? Have another 1 minute. Yeah, another working template, the empty one, so the blank one. So this one is the free version to segment 2. So I have here. Okay, I'm going to solve this one by using energy equivalent method. So how is it? So for the equivalent method, you have to transfer. So we are going to either transferring this one. Either you are going to transfer this one, remember, to be at here, or you're going to transfer this one to be at here. So it's up to you. We want to keep this M here, or you want to keep K here. But remember, yeah, you have another one, this one. Just not it's KP. This is KP. Okay, so if I can simplify the whole system to become a very simple one, so you have as such. This one, S. So this one, this one is no longer mass. You don't have mass anymore here. You don't have mass anymore here. You have KP. You have put it only one spring. It's not. This is not free body diagram. This is not free body diagram. Remember that. Put only one spring. But this one spring represents 2k, and the distance is y. The distance is, and we have mass just now because you have mass here. So now let's assume that you are going to move k to be part of it. So you will have as such. You will have here the mass will remain as it is. This one is at one point about O, about O, about O. This is no longer K here. You have a spring, only one spring, and this is your M. This one is your K equivalent, or put it as K prime, isn't it? So your K equivalent now is equal to your KP here plus 2K that you move. So your aims now is to define what be your K here. You understand me? Or if you don't, if you a bit confusing, doesn't matter. You can put K here also another K, but basically the same thing, yeah. Because this one is K plus K is become 2K. So you do this one, you can solve. This one is not very difficult. I'm not going to do this one. I'm going to do more challenging solution, or more challenging problems. Okay. Let us now move to the next one. I'm going to give you here. All example, this one is in your notes. I'm not going to do in detail. I'm going to share only how to go about it. So you can turn your notes, you can turn your solution. If I can open up another file which give you your books on the 15th of December 2021. This one. So you can turn to page 257. Because if I do everything, so it's no point because I keep repeating and keep copying back whatever you have in your notes. So it's no point. Better still that I do another equation which is not in your notes. So you have this one on page 257. 257. Yeah, this one. 257. We done this one earlier and we completed, and then we move to this one. We already done this one. Then here, this is the solution that we are going to look for. Okay, look at how configuration or perhaps the construction of a free body diagram. First foremost will be solving this one by using Newton's law. And this is very typical in your exam, but it will not be specifically mentioning about what method are you going to use. So it basically asking about determine the natural frequency of the system if the rod is displaced and then it released. So that's about it. So if you are keen to use Newton's law, for example, the free body diagram is compulsory. So what you have is this the actual one, then you displace, it become here theta, theta dot, theta, double dot. Isn't it? That's what you have here. So but remember this one, this spring will not allow you to move. It always again the direction of motion. So that is why pointing downward. Same thing here. You have another one. It's always again this one. It's always again this one. So it's pointing the other one downwards. And the displacement between these two, you have the displacement of here and also displacement of here. And this one is typically applying segment equation. Remember? Segment equation. Isn't it? Okay. So that's about it. Then when you have as such, then you start doing the analysis. How is it? It's not very difficult, class. It's very interesting here. So applying this one, Newton's law. In Newton's law, you have two equations, one coming from the moment, the other one coming from the formula. This one is the angular, and you need to use moment. So you are saying that, okay, anything against this one will become negative. So you will have K1 and 1, isn't it? Multiply this one, look at it, you have 0.2 cos theta. Okay, I'm going to comment about this one. You can put this one because you know that the theta is approaching to 0. It's very small oscillation. So this cos theta is basically what? When cos 0 equal to what? When cos, when theta approaching to 0, so cos 0 become what? Cos 0 become what? 1. So you basically can ignore this one because this is a small oscillation. How do you know small oscillation? Because it mentioned here, display slightly, meaning that the theta approaching to 0. In mechanical vibration, when you want to disturb the system, remember the vibration is about disturbing a system. You don't have to display so much. You have displaced a small amount, a small of theta, then it will be vibrating. Okay, then you have this one. It becomes, so if you put here K1 x1 multiplied by 0.2 is also correct, but you need to put that one a small oscillation, then it's correct. Okay, you put a small oscillation. This one I think everyone know. If you are in engineering line, you know that, or in the mathematics, you also know this one. This one cos theta basically. Okay, so this one you change this one, in form of what? In term of bring up here this one. Same thing as this one. You have K2. You also can ignore cos theta here. This x2, you put in the x2 is equal to that one. So you have as such. Because at the end of the day, this cos theta, when you're saying here this one a small oscillation, look at here, cos theta equals 0 and cos theta equal to 1. Because the small oscillation. Okay. then this one you solve, okay, fine. But when you have another one is I not is I not. Okay, I'm going to talk about this one a bit. Okay, so allow me to have this one. So the system that we have here is combination. It's a compound. You have the compound of this one, rod, hinge at one plane. This one have mass. So this one is M. This one is another M. Put it M1 and M2. As you have this one, you have to apply parallel axis theorem. The parallel axis theorem that you learn in what they call it in dynamic in mass moment of inertia simply tell you that if I'm saying this one is O, for example, yeah, your IO is equal to I center mass plus the M H square. Remember this one? Have you come across of equation? This equation in my class I call it PAT, parallel axis theorem. Have you come across the equation? Class, have you come across of this equation in the mass moment of inertia? Could anyone respond about it? Yes or no? Yes, thank you. So you come across of this equation. So this equation is not very rare to you, yeah. So and you know that this is the I at center mass, and you have another one H. So you need to define what H is. Okay, first define the I bar is the I center mass. So if this one is if this one is uniform, so this one will be at center mass. So this is the I at center mass. This one is I at center, called CG. Okay, and what is the H? H will be the distance about rotation to the center mass, and these two lines must be perpendicular. That's what they call it, perpendicular what? Parallel, yeah, sorry, parallel axis theorem. Must be parallel, it's not perpendicular, sorry, must be parallel. And this one we call H. This was your H. Must be parallel, yeah, this line, these two lines must be parallel. These two lines must be parallel. If you're talking about this one, if I say this one is the X, Y, and Z, for example, same thing for Y at top, same thing for Z. This is Z, but not for X, because X will be fall at here. So Ix becoming 0. Isn't it? This one will becoming what? Only I, Y, and I, Z. Am I correct or not? Is it the same thing that you learn in dynamics? Or I'm you feel another theory here? Am I correct or not? Yes or no? Correct, yeah? So this I bar is the I center mass. You have to look from books or reference, because you have two. I bar is ml squared by what? By ml squared by anyone? By 12. This one is in books. How do you get this one? You have to do some integration and also multiplication due to the I is equal to integration of, remember, from the x something to x something. This one is your what is R. We don't learn this one, we don't learn this one. We are going to put this one, use this one only. This one in table. You have to memorize this one. Okay, so that is one thing. So if you have this one, then if you want to look for I naught, for example, so simply give you the ml squared divided by 12 plus the m is m. The h will be the measurement from this one. Correct. So in the equation here, they provide you what? They provide is 0.2 and 0.4. This one is 0.2. A bit more, yeah. We are running out of time. This one is 0.4. So basically 0.6. This one must be 0.1. So this one be 0.1. You will have m l squared by 12 plus your m h will be 0.1 square, and this l is your length is 0.6. So you go back to the solution. Look at here. How do this one is in your solution? This one is called parallel axis theorem. Okay, another one more minute, yeah, because you have compound here. One will be the solid or perhaps the uniform bar. The other one you have here mass mass. This one is 0.2, 0.4. So you need to use I, another I, but this one is I equal to m k square, where your k now is equal to 0.4. Because this SM rotating about point O, this one, you use m k square. So you go back to this solution, you have another one. Is that clear? So you have to add up this together. We call it I total, which together will give you 0.52. So I will stop here. So inshallah, when we meet again, we are going to continue this one, the whole exercise. Okay? Any question up to here? But you can start doing this one on your own before you join me in my class on Wednesday, perhaps, inshallah. Any question at the moment? Until here, any question? So whatever you learn in dynamic, sometimes in static, where you have a static deflection, so you basically bring up here, and we are going to use that one to be part of your solution. That is what the prerequisite for this course will be, static and so dynamics. Okay, there is no questions, so I will stop here. Thank you very much for participating in my class virtually. Thank you for attending the class. So really hope that you understand the course, the topic that we learn here. So I will see you inshallah on Wednesday. So with that, I would like to end my class with Assalamualaikum warahmatullahi wabarakatuh.